Hey guys, Camille Schreier, Miss America 2020 here, and I have to admit something to you. I really like food. Now, I don't know if this is just because I love science, but have you ever been eating? Maybe scrambled eggs, eating breakfast, and you kind of look down at your food and you wonder, what happens when you cook your food? So today I want you to join me in learning a little bit about the science behind your favorite foods. I told you that I love cooking, but I love baking probably just the same, if not even more, because even more so than cooking, baking is equal parts art and science. And that's what makes it so precise. So we're gonna make some cookie dough. We're gonna use an egg in our cookie dough, which is pretty standard in your recipe. It's the reason why you don't wanna eat raw cookie dough, because raw eggs can carry a bacteria called salmonella that can make you sick. But eggs serve a really special purpose in cookies to keep them sturdy and together. So I am gonna whip up a batch of my favorite sugar cookie dough, and we're gonna stick it in the oven and watch what chemical changes happen. So I just got my dough out of the refrigerator. It was in there for about 45 minutes. It gave it a chance to kind of solidify and get a little bit harder before I got to bake it. And now I'm going to just portion it out into my cookies before I put it in the oven. What I want you to really notice about my cookie dough before I put it in the oven is the texture. So this is soft and it's malleable, kind of like Play-Doh. I can squish it in my hand, I can break it apart, and this is really going to change once I put it in the oven, and that is going to be representative of the chemical changes that are actually happening within my cookie dough. So look at this now, and then I want you to compare that to what the cookies look like after they come out of the oven. Now I'm gonna take these and stick them in the oven at 350 degrees Fahrenheit for about 8 to 10 minutes. So while my cookies are baking in the oven, I want to talk about what is happening to them inside that oven. So the first thing that happens, the cookies go in the oven, they are room temperature. They start to warm up with the air around them. My oven is set to 350 degrees. So once those cookies reach about 92 degrees Fahrenheit, the butter in them starts to melt. The cookie then starts to spread out, as you would imagine, as something is melting. Butter is an emulsion. It's a mix of fat and water. The water and the milk products start to separate out, and then that water starts to kind of bubble up, and the cookie kind of starts to push farther out. So at 136 degrees Fahrenheit, this might be your favorite temperature for cookie baking, because it is the temperature where the salmonella that might make you sick in cookie dough no longer can live. And so after that point, the salmonella has died and the cookie dough is technically safe to eat. At 144 degrees, the proteins in the eggs start to denature. They start to coagulate and become solid. Now, a little bit farther up in temperature, at 212 degrees Fahrenheit, that is the boiling point of water. That is when the water that is in that cookie starts to evaporate out. So our cookie kind of dries out. And when that water evaporates and goes away, it leaves pockets inside of the cookie, which make your cookie light and fluffy. And we used a leavening agent. We used baking powder, which has sodium bicarbonate in it, which is baking soda. And that helps with this too, because that sodium bicarbonate reacts with acids within the cookie dough. It forms carbon dioxide, which also leaves little bubbles and pockets within your cookie and makes it nice and light and fluffy. Now, 310 degrees Fahrenheit is an extremely important temperature for cookie baking. This is when a special reaction happens where proteins and sugars start to interact. And this is the time when we start to smell the aroma of the cookie. It's a good signal that your cookie is almost done. And this is a really special time. It kind of gives your cookie that brownish color as the proteins and the sugars start to kind of meld together and wake up and make those really awesome flavors that you know about baked cookies and other baked goods. And then finally, depending on how hot your oven is, at 356 degrees all the way up to 390 degrees, we can get caramelization. And you probably know what caramelization is if you've ever eaten a caramel. And caramelization is kind of the browning of the sugars within that cookie or in a baked good. It's what makes caramel, and it kind of has like almost a bitter but smoky, pungent taste that we associate with caramel candies. So I think our cookies are almost done. We should go check them. These cookies are super, super perfect. They are not too brown. They're just a little bit crispy, just the way that I like them. And I'm gonna take them off this pan so they can cool down, and then we can taste one. So my cookies are straight out of the oven, and it's only been 8 minutes since I put them in. And they are completely transformed from the cookie dough that I originally put in my oven. It was mushy, it was like Play-Doh. And now I have a solid cookie that's nice and crispy in only 8 minutes. So many chemical changes happened within this cookie. We had butter that melted and water that evaporated, and we had proteins that denatured and they became solid. So many chemical and biological reactions happened within my cookie. And there's so much science behind the cookies that we make and eat, and that's true for so many foods in our home and in our life. I hope that you enjoyed learning all about the science of cookies. I think science is pretty sweet, don't you? And the next time that you make a batch of cookies, I hope that you remember that science really is all around us.